Hello class. Today we're going to be looking at Unit 2-1, which is about relations and functions. Now, relations are, as they sound, a relationship between two numbers. Technically, it's going to be defined as a set of numbers related in some way. In our minds, we're typically going to associate them with our x and our y coordinates. So it's the relationship between our x coordinates and our y coordinates. There are a variety of ways to show relations. We can show them either as ordered pairs in the form of x, y, in what we call mapping diagrams, in tables, or we can display them as graphs. To start with, let's look at how we can call relations as ordered pairs. So, on our standard x, y ordered pairs, we can use the points 5, 4, 1, 8, and 2, 3. We're going to be using these points throughout our next few examples. Remember that our points go x, y. So the x coordinate is first, and then the y coordinate. With a diagram, we're still going to be looking at the same ordered pairs that we were looking at previously. So in our diagram, we have two tables. So one of these tables is our x coordinates, and the other table is our y coordinates. Typically, the table on the left is our x, and the table on the right is the y. Because remember, the x comes first, and the y comes second. So with our tables, we typically put them in numerical order. So I've started with x, and I've gone down 1, 2, and 5. And then for our second table, I've also put them in numerical order. So we start with our y, and we go down 3, 4, and 8. And then once you have all of your numbers together, you draw lines between the numbers that correspond together on your ordered pairs. So the x goes with the y, the 1 goes with the 8, the 2 goes with the 3, and the 5 goes with the 4. We can also show it as a table. So tables are very similar to diagrams. However, we show them in one compressed unit. So our table is here, and on the left-hand side of our table, again, we have our x's. On the right-hand side, we have our y's. And then we order our x's numerically. So we go 1, 2, 5. And then immediately to the right of the x, we have the y value that it corresponds to. So we have 1, 8, 2, 3, and 5, 4. Lastly, we can show relations as graphs. So when we look at a graph, we are showing that each x value corresponds to a y value. Remember that x values go horizontally along the x-axis, and our y values go vertically along the y-axis. So when we plot our points, we're looking for the intersection of our x and our y-axis. So we have our points of 2, 3, 5, 4, and 1, 8. Now that we've talked about relations, we want to talk about the domain and range of a relation. So the domain is going to be the set of all x values for a set of numbers or for a relation, and the range is the set of all y values. So from the ordered pairs that we've been talking about, so we have 1, 8, 2, 3, and 5, 4. Our domain is going to be all of our x values. So this is going to be 1, 2, and 5. Whoops. And we typically enclose them in braces. And our range is going to be all of our y values. So in this case, it's going to be 3, 4, and 8. Do notice that I put them in numerical order. Typically, you will find them in numerical order. We can also describe domain and range as an inequality if it's continuous, as it is in this case. So notice here that I have a line segment, not a line, so it stops at these points. So I want to start out by looking at my x values. So for my x values, I start out at -1, -2. So my smallest x value is -2. So I'm going to go ahead and write that in. So I'm going to say -2 is less than or equal to x. And then my largest x value is 1, 2, 3. So my graph goes from -2 to 3. And so my domain is going to be -2 is less than or equal to x is less than or equal to 3. In contrast, let's look at the range or the y values. So my lowest y value is -1, -2, -3. So it's down there. So I'm going to write negative 3 as my range. And it's going to be negative 3 is less than or equal to y, which is less than or equal to, what's my highest y point? Up 1, 2, 3, 4. So my largest y value is 4. So I would describe the range as negative 3 is less than or equal to y is less than or equal to 4. In some cases, our domain and range may extend infinitely. So in this case, our domain for our x values, we can see it goes on infinitely because of our arrow, and so it's going infinitely to the left. So our domain to the left is going to be negative infinity is less than or equal to x, and to the right we are also going to negative infinity, because if this line were to extend, it would eventually go all the way over here. So we're going to say negative infinity is less than or equal to x is less than or equal to infinity. Now looking at our y value, our smallest y value is 0. So we don't ever go below 0. So we're going to say 0 is less than or equal to x is less than or equal to, and then for our y value, we do in fact go up to infinity in both cases, so we're going to say is less than or equal to infinity. And so that's going to be our range for that. Oh, and that should be a y, my apologies. If I can figure out how to erase. Okay, I'm just going to erase the whole thing. So we're going to say negative infinity. 0 is less than or equal to y is less than or equal to infinity. The last thing we're going to talk about are functions. And so a function is going to be a special relation that has only one x value per corresponding y value. And so a relation may have multiple y values for one x value, but it can only have one x value for each y value. That may sound confusing, but we're going to look at some examples on how to determine how each one, whether or not it's a function. For an example, let's look at two sets of numbers. So on our left-hand side we have set 1, and on our right-hand side we have set 2. Let's look at these case by case. So for set 1 we have an x value of 1 corresponding to a y value of 2. We have an x value of 4 corresponding to a y value of 5, x value of 3 corresponding to a y value of 1, and x value of 1 corresponding to a y value of 4. So we want to look and see if we have any two x's that correspond to different y values. In this case we have a 1 here and a 1 here, and they're corresponding to different y values. So this is not a function. Let's look at our second set. Our second set has negative 2, 4, negative 1, 1, 0, 0, and 1, 1. So in this case our x values we have negative 2, negative 1, 0, and 1. Now, even though we have two y values that are the same, 1 and 1 here, they correspond to different x values. So this is okay. This is a function. So remember that it's only the x values that we care about when we determine whether or not we have a function. When we're looking at our diagrams, we want to look and see if we have any multiple lines going from one x value to two y values. So on our left hand side, on our set 1, we have from negative 1 we have negative 1 going to 2, and we have negative 1 going to 4. So since we have two lines coming out of negative 1, that means that that's not a function, even though 0 and 1 both follow our rules. On our right hand side, we want to see if we have any two lines coming from one number. So we go from negative 1 to 2, that works out, 0 to 4, 1 to 6, and then we have 2 going to 4. So this works out. Note that we can have two values from our x side going to the same y value. We just can't have two lines coming out of the same number. Most often with a table, you're not going to be able to have a set that doesn't have, that's not a function, because with a table you want to order it numerically, and so typically you have your x values corresponding to your y values, which means that you're not going to repeat the same x value twice. And if you do repeat the same x value twice, so I'll just quickly draw one. So if you have 0 and then 0 again, then because we have two zeros here in our x value, right here and right here, this is not a function. Whereas over here we have each x value corresponding to one y value. So this is a function. Lastly, when we look at graphs, in order to determine if something is a function or not, we want to see if each x value corresponds to multiple y values. So looking at our right hand side, starting here we don't really have anything here, but as we move out, we notice that we have multiple y values for each x value. On our right hand side, as we go up and down, we notice that we do not have x values for the same y value. So our left hand side is not a function, and our right hand side is a function. And there's a special test that you can use whenever you have a graph to determine if you have a function, and this is called the vertical line test. And the vertical line test is going to say that if you pass a vertical line through a function, if it hits multiple points, then it is not a function. So notice that this one, if we were to pass a vertical line through it, then as we pass through it, we are hitting multiple points each time. Whereas on our right hand side, as we go from left to right, we never hit the same value twice. So that's going to do it for our lesson on relations. Hopefully this has been informative, and then tomorrow we will be doing some practice on this in class.